All right, JJ, Dominic, Dakota, we're back again. Tuesday, lesson 91. Should be a fairly somewhat short explanation. We'll see. Solving absolute value in equalities. Example 1, page 602. It says graph the absolute value of x is less than 4. Hopefully you remember that absolute value of any number is positive. So the actual answer to this is it could be a 4 or a negative 4, because the absolute value of that is 4. So to graph it, it says is less than 4, which means it cannot be any bigger than 4. It has to be less than. And if we're saying it's less than, then it's going to be a conjunction, a connection of the two. So less than means it is in between there. So for B, when it says absolute value of x is greater than 7, here's our line. Again, same thing, negative 7 and 7, but it's greater than. Well, we know that greater than 7 is going to go this way. What about absolute value of a negative 8? Well, negative 8, the absolute value is 8, which is greater than 7. So this would be a disjunction. It goes in the opposite directions. That is the easy explanation for today's assignment. Now it does get a little bit more involved. 2a says the absolute value of x plus 7.4 is less than or equal to 9.8. Now this should look fairly simple. You've done these things before. If we're adding here, we're trying to get the absolute value of x by itself. We need to bring it across. If we're adding here, we need to subtract. So the absolute value of x is less than or equal to 2.4. So to graph that, guys, I'm all about doing these easy. 2.4, negative, positive 2.4. If it's less than, again, a conjunction, equal to means we fill in our circle, means that it's going to connect them. Less than, a conjunction. Okay? Hop down to C. And negative 2, absolute value of x is less than negative 6. Now, side by side means we're multiplying. So that means I need to take it over and divide by negative 2. Hopefully you remember it goes back. When we take a negative across our inequality, it flips this inequality. So we now have the absolute value of x is greater than 6 divided by 2, 3. Negative divided by negative is a positive. So x is greater than 3. So we have positive 3 and negative 3. Greater than means we split. And you grabbed it. What about example 6? Or sorry, example 3. Example 4 is very similar. Example 5 talks about setting them up and solving the same thing. Example 3. And then this will be it for lesson 91. Example 3a says absolute value of x minus 5 greater than or equal to, less than or equal to 3. And they want us to solve. Well, here's where you have to use your brain a little bit. Okay? We know we're still dealing with absolute values. and it's going to be less than or equal to 3. So we have to say, excuse me, we have to say that what minus 5 is going to give us 3. So technically, we could remove the absolute value and say x plus or minus 5 is less than or equal to 3. And then we have to do both of those. We need to add 5 to 3, and we need to subtract 5 from 3. So we can say x is less than or equal to 8. In terms of if we take our plus cross, and if we take the negative across, then it flips that sign, and 3 minus 5 is a negative 2. Does that make sense? Yes? No? No, it can't be a negative 2. We're still taking that negative across, but it can't be a negative 2. Negative 2 minus 5 is not going to be less than 3 or equal to 2 minus 5 does the work. So, pay attention to your signs there. So I have x is less than or equal to 8, and x is going to be greater than or equal to 2. So to graph that, simple. 2, 8, it is less than or equal to 8, which means it's coming this direction. It is greater than or equal to 2, which means it's going that direction, so they will connect. Okay? So B. Let's see, like x plus 7 is greater than 3. Okay? So to hopefully explain it a little bit better, we have to say x plus 7, the absolute value of x plus 7 is going to be greater than 3, or the absolute value of x plus 7, absolute value is going to be less than a negative 3. Okay? And now we solve. So, 3 minus 7, in this case, 3 minus 7 is going to give us a negative 4. Over here, I'm subtracting again, x is, greater than, x is less than negative 10. Negative 10, negative 4, it's what the negative 4 is greater than, going that direction. Less than negative 10. Okay? So, graphing inequalities, you must solve for those. So, for lesson 91, let's see. We can cross out number 9, number 10, $25, 29. So do not do 9, 10, 9, 10, 25, and 29. Next up, lesson 92.